Manufacturing is the largest and most critical sector of Europe's economy. However, its heavy resource usage, combined with rising energy prices of up to 40% since 2022, pose a serious challenge to competitiveness.
If any cost increase like that should happen again, then I believe it would have a very strong impact on our industry. For sure, it is going to help competitors from around the world.
Industry uses huge amounts of resources, especially energy and water. Industry and the energy sector together account for 40% of total water consumption in Europe, and industry alone consumes nearly 1/4 of all final energy. A significant portion of energy used in industry is simply wasted as heat, but this is where great potential lies. European industry's total surplus waste heat is estimated at nearly 3,000 terawatt-hours per year. That is almost enough energy to heat every residential building in the entire European Union. Now, the EU-funded Project iWAYS has successfully turned this huge potential into profit. They developed a Heat Pipe Condensing Economiser technology, HPCE for short, which captures what otherwise would be lost.
The whole idea came about from a dream of mine to come up with a concept to enable factories without chimneys, so to eliminate the need for exhausting these dangerous gases to the environment. And the only way you can do that is by actually recovering the heat that is being wasted and condensing all the volatiles and the moisture that exists in those stacks. And that's really the main motivation behind the Heat Pipe Condensing Economiser.
And this is how the technology works. The HPCE is based on heat pipes, which are sealed and filled with a saturated working fluid that transfers heat quickly and passively from the heated bottom section to the cooler top part. In the HPCE, many of such heat pipes are assembled in a specific pattern. A hot exhaust stream passes through and transfers the heat to the upper part, where cool water collects the heat. During this process, condensate runs down the pipes and is collected, together with other wastewater from the HPCE system, and sent to a water treatment plant. The treated water will then be reused. The HPCE is designed to reduce freshwater consumption by up to 60% and to recover up to 80% of the heat. But the HPCE is not simple off-the-shelf technology. For the system to be effective, it must be built according to the needs of each industry and company.
From design point of view, it's quite demanding. If you look at different factories, you will not have the same composition for the exhausts in those factories. Once we know that, we know which components we are going to condense, then we can design the Heat Pipe Condensing Economiser in groups of tubes, basically, and each group will be responsible to condense one of those volatiles.
To test the prototypes in practice, the iWAYS team installed 3 different demonstration sites. At the chemical production facility Alufluor in Sweden, the HPCE was built to endure harsh corrosive exhaust gases. The captured heat warms fresh water to more than 60 degrees Celsius, which is used to clean equipment like the reactor. The system also reuses the recovered condensate after it is treated to remove fluorides.
We have been running it for a couple of months now, and it has worked very well. So we have got the transformation of the energy from the gas to the water, and we have also seen reduction of the emissions. We continue to strive lower and lower.
At Cheope Ceramics in Italy, the HPCE is already achieving good results after just a few months of operation. The goal is to recover 6 gigawatt-hours of heat annually. This heat is used to preheat the air for the spray dryer burner, reducing natural gas consumption by about 70 cubic meters per hour. The recovered water is treated using ultra and nanofiltration to achieve the purity required for high-quality applications such as glaze preparation.
The first months were extremely positive and successful. We can say that every hour of operation we are recovering the amount of energy that 20-30 households use during winter time. This happens every hour, just recovering energy that otherwise would be thrown into the atmosphere and would be lost.
At the Tubacex steel plant in the Basque country, the HPCE is applied to the hot flue gases from the furnace. The recovered thermal energy is reintroduced to preheat process streams, with early data showing recovery of up to 30% of the process heat, significantly reducing natural gas consumption and emissions. The condensed steam is treated using advanced membrane systems.
It is actually a hydrophobic membrane that allows only water vapor to pass through. So at this stage, the effect is very high, and we can remove about 99% of the contaminants, either organic or inorganic.
The goal is to recycle up to 95% of all industrial wastewater, moving the site toward a near zero discharge model.
We are going to lower the dependency of that industrial process from the price of the fuel. We can strengthen the industrial process because it will depend much less on the external factors.
The iWAYS concept is validated across 3 critical industrial sectors and aims to pay for itself within 2 to 3 years.
The biggest success we have in iWAYS is the units that were implemented in the 3 demo cases were invisible to the process. That is key for us. Implementing those units didn't impact the factory's operation. The factory was operating as normal. These systems were just sitting there, recovering heat, recycling water, and not causing any disruption to the process. And doing that in a cost-effective way also. And that for us was really a dream that we were dreaming about at the beginning of the project, which became a reality at the end of it.
By maximizing the recovery of resources, the HPCE system offers the economic resilience that European industry needs to remain competitive and secure its future in the face of global uncertainty.